Assalamu alaikum. My name is Imran Matara. I'm head of the ground engineering team within WSP in the Middle East, and I'll be your moderator today. So, as has been introduced by Dr. Marwan, this is a very vast and interesting topic, and very relevant to this region as well. And basically, we've also had quite a few presentations already which have introduced that there's a lot of risk and uncertainty below the ground that we all know. And we're working on very high, complex, challenging projects, building tall buildings, high-rise, mid-rise buildings within the region. So the question that we're going to pose today, and which I'm going to ask or pose to my panelists, will be to do with whether there's any over-conservatism currently within the soil structure interaction analyses and work that we undertake within the region. So I'm going to try and break it down into maybe three subjects, and I'll be asking each of our panelists in turn to maybe elaborate and maybe discuss some of these points. There may be some agreement or disagreement. I'm not really taking any side at the moment. I'll just leave it to the panelists to hopefully make their arguments and make their suggestions, or whether we do feel that there's over-conservatism, or whether we feel that no, the industry practice is good at the moment. So for the first question, or the first topic under this subject, I'd like to ask the panelists of whether we feel that the current ground investigation and the geotechnical parameters that we're using within our soil structure interaction studies, whether there's any over-conservatism within that. And I'll start with Dr. Marwan. Ladies first? Okay, we'll do that. All right, we can start with Ria.
Hello. Yeah, ladies first.
Okay.
In time with the International Women Engineer. Hi, everyone. Good morning. I'm Rhea Albelda from Robert Bird Group. I'm leading the geotechnical team there. It's a Sirvana Jurong company. So just to reiterate the question whether there is over-conservatism in geotechnical parameters we used for SSI. I would, from my opinion, yes. I think there is often over-conservatism, and it sometimes often starts as early as the interpretation of available ground investigation. So there are a lot of factors contributing to this over-conservatism, but I would like to highlight a couple of them, which in my opinion drives the over-conservatism. First is the time constraint. I mean, I'd like to highlight in the region that it's always in a rush. So whether we have enough time to do a quality investigation, that's the number one aspect. Second thing is like there has been a lot of discussion about the site investigation, whether we have enough information or the quality of the data. It drives conservatism as well. Obviously, if we don't have enough information, enough data, as well as the quality, then we opted for over-conservatism. Third, in my opinion, is the applicability of parameters. You know, whether, for example, when you're designing raft foundation, you do the SSI, but if you don't understand the parameters that govern the design itself, you will go conservative. So these factors, in my opinion, contribute easily to over-conservatism. But how we can improve it, I think in my opinion, we start from the beginning, which is ensuring that we have high quality investigation. By how? You need to understand first what's the geohazard risk within the project. If you don't understand that, your testing is not going to be related to quantifying those risks. And what happens next is like you're just blindly interpreting the data and a tick-off box exercise. And I think last but not the least, I have limited time so that it gives other. I think I will recommend a collaborative effort between site investigation contractor and consultant by supervision. So when you supervise and ensure that you have a high quality way of testing, you'd expect high quality data. And so therefore it follows all the rest. That's from my perspective.
All right, thank you, Ria. We'll move on to Hadi. You want to go next?
Hi, good morning, everyone. I'm Hadi Kulut, the Director of Geotechnics in Jacobs. Yeah, I agree. We have conservatism. Basically, what was discussed in the previous talk, that we have limited information, and I, as a designer, when I see I don't have as many boreholes that I need, I just tend to push the design lines a bit lower. It's like because of all the things that I have in mind as liability and what if this goes wrong, but that may result in unrealistically being like on the conservative side. Yes, we don't know how the layers are varying between the boreholes, but by bringing the UCS further lower on the design, we are not helping, we are not solving that problem. So we are kind of sacrificing on some design parameters because of our uncertainty about the investigation data. So if we tend to get more realistic, but like better understanding of ground conditions by all these new developments of the investigation, then we can look at our approach that, okay, we don't need to be that conservative on adopting these design parameters during interpretation. Another cause or the reason that we have for this conservatism that I see is that we are relying on a lot of correlations between the site investigation results and what we use in the design. The correlations basically done from the back analysis of tests, for example, pilot tests in 60s and 70s, that's like ASHTO design is based on. Those correlations have some conservatism in them, and we are still using them for like after all these developments that we have. We are not relying on the data which we are recording on sites enough because we can look at those and, for example, establish higher stiffness values based on the recent site investigation data, back analysis that we have from like zone load test, pilot test. I think there was a very interesting presentation by Dr. Marwan a while back on the back analysis of pilot test results and the stiffness of the ground that we are using. So all those recent data and investigation and developments, we need to start incorporating them in our design as well.
Thank you, Hadi. Good insights. Finlay?
Okay, can everyone hear me? Cool. I'm Finlay Liebrich. I'm the Practice Director for Tunnel and Geotech for AECOM across Middle East and Africa. I've been here about 20 years now. I want to concentrate on 3 points to do with the over-conservatism. The first point has been covered a bit by my colleagues here, and also it's been covered in the 2 previous talks, which actually dovetail well into this. So we had ground models, engineering, geology, and ground models. That's one of the most important things. Ray mentioned about getting your geohazards right. If you don't know what you're likely to encounter on the site, you probably really shouldn't be putting a borehole in the ground. You should go back, okay? So it's getting that ground model right. Taking that into the second talk, we talked about how to basically fill in between the dots, okay? How to color between the dots. And that's really important. So once we get our ground model, once we get our boreholes, have we got enough information? And Hadi was here talking about that, which is really good. So it's really holding that together and not thinking that there's one individual item which goes to our whole geotechnical model, which feeds into maybe our 3D finite element analysis, which then spits out a number, okay? It's several things, there's several layers there which we need to build up. So that's the first point. The second point is overcoming, do I want to use prejudices as a term? Overcoming local, let's say set local knowledge, okay? How many times have we all been there that the local GI contractor or the local or a consultant has sat there and said, nope, your bearing capacity is this, your your pile length is this. We don't have piles less than 13 meters long. You can tell that's a specific I was told by someone once. Okay, it's things like this, and you have to almost break it and get into a stand-up argument with people, and hold your ground on it. Unfortunately, so a lot of time there'll be people who will claim that they have all the local knowledge. Okay, and the third one, which I'm sure Dr. Marwan will take on, is the codes. So in Dubai, in the code, there is a conservatism because, we're going to talk later about combined pile drafts, I think you had on the agenda there, Imran. But within the Dubai codes, it actually says you have to assume all the load is taken on the piles. It will go through and explain everything, and then there's a little sentence at the end which says all load taken on the piles, which precludes a combined pile draft in Dubai at the moment. So it's really those three areas: the ground model, the apparent local knowledge, and then the codes. That's where the over-conservatism is, is coming. Okay.
All right, thank you. All right, okay, so we've heard from three consultants.
Yeah.
Now we're going to hear from Dr. Marwan to give
Very
the
conservative.
opinion from the authority.
Yeah. Just see, I want to highlight two different things because, first of all, we have high-rise building and mid-rise building. We have deep foundation and shallow foundation. So I will start with high-rise building. We could consider it as a deep foundation. So we have three main points, in my opinion, should be considered. First of all, as mentioned by Rhea, a proper site investigation test, which include and give you the proper geotechnical parameters, which you can use it in your geotechnical modeling with interaction for sure with the structural modeling. The second point, which related to the preliminary test pile, because we are talking about the foundation, the PTP. I think, okay, maybe combined pile foundation is still not approved, but we have huge room by do back calculation and using PTP within the Eurocode and reduce our safety factor and make more economical design, and especially when you try to use the finite element to back calculate the PTP or the static load test or other ways as well. The third point, which is very important in my opinion, the interaction between the geotechnical and structural engineer and creating a proper geotechnical model. That's very important, using the right parameters, using the right model. Specifically with Imran, we have a lot of discussion with relating which you should use hardening soil, you should soil model, the soft rock, we should consider it as an, for example, we can use hardening soil with it or Mohar column or whatever. Additional tests for sure can make it more clear and can make a lot of saving in our foundation. Back to the point highlighted by my colleague Finley, I think the new Eurocode I just recently came from the ISSMG conference, and I think in the new generation we attended the workshop related to the second generation of Eurocode, which seems it will be clearly mentioned in the code that it will be allowed. Now, it will be considered here in Dubai or not. This is a lot of discussion will happen, but I think slowly we are getting to the point, and for sure we will have more room in our new codes, which will allow us to reduce the conservative approach in our design. Thank you.
Okay, thank you, Dr. Marwan. Okay, I think we covered quite a few of the topics within that round. The next one, I think maybe we'll go on to, which I think no one has really, well, we've touched on it a little bit. I think we talked about the preliminary test piles from Hadi, mentioning maybe we should use more of that to back analyze and then maybe use that as in our design loop back into the design and use that because it's very useful data. So maybe the next one we'll talk about is there a role for instrumentation and monitoring in our soil structure interaction modeling to try and reduce any over-conservatism? So I don't know who wants to start. Shall we start again with ladies first?
Sure. Instrumentation and monitoring, yes, absolutely. It will help. So the instrumentation and monitoring will help us pave the way from being conservative to more of a performance-based design. So the like of, let's say, as an example, you've got settlement markers, load cells to put into your piles, extensometers, these things that will help you understand or take an actual reading during construction. And basically, when you do your soil structure interaction modeling and compare it with this, you'll have a validation. So as you like do more of this instrumentation and monitoring, gather the data, you will have a situation whereby you can establish a more of a project, or let's say region specific correlations, let's call it that way, rather than solely relying on empirical equations that are often done in a separate region in a different environment. So we collect all this data, we establish this correlation that will give us a more of confirmed design and not being conservative. I think as one of example is the preliminary test piles approach, that would help establish the correlation of designing the piles in the region itself. There had been a research that was done by myself and Dr. Marwan as well in that case. It's one of the examples, and that would pave a way of moving away from the conservatism. Tomorrow I will be speaking on one of the topics that relates to how important the instrumentation and monitoring construction verification topic. So I guess, yes, it absolutely will help us.
Okay, thank you. Thank you, Ria. Hadi, you want to go next?
Yes, I think, as all of our colleagues know, we have almost INM instrumentation monitoring for all of projects. So we do the specification, it's done on site, and as long as nothing goes wrong during construction, it's recorded and archived and left, basically, forgotten about. We need to start looking and using those data, start to back analysis. And this needs a kind of collaboration between all involved parties, the designer, the engineer, and the authority, to because there are contractual requirements that a project we have done a design and it's been approved and it's implemented, but we need to do more work and start looking at, said, okay, if we have a very long project, thousands of piles, and before we started constructing the latter ones, we have pile load tests and the first ones, and we have other type of testing, and we have seen how they perform. Can we start implementing? Can we start revisiting our design due the course of the process? Because that's really going to change things. So we need to work out, with all the involved parties, how we can define these workflows, and basically a willing from all involved, the different teams, that everyone is willing to do that, because that's in the end to the benefit of the project and everyone else, from the sustainability point of view, cost saving. So yes, we do the INM, we hardly use it, and so this needs, again, kind of participation from everyone, just starting even from universities to look at, to start digging the information and see how they can correlate, relook at the correlations that we have based on the test results. We have a huge database, but we need to start looking at them and using them.
All right, thanks, Hadi. Look, I think with the instrumentation monitoring is very, very important. I think we know that. But one aspect or one question that can be raised, and I think Ria probably raised it right at the start, was the time pressures that we're under. So, Pinlay, bearing that in mind, how do we convince our clients and developers to use instrumentation monitoring?
Okay, I know I'm not meant to ask the moderator a question. Can I raise the observational approach, or do you have that as another topic?
That's fine. You can go with that.
Okay. I will get on to the observational approach in about 30 seconds. When we do instrumentation and monitoring, and this will also help with the client, is you have to have a purpose and you have to know what outcome you're hoping to get out of this, okay? So I've mentioned the observational approach. There's two basic methods for the observational approach, okay? The first one is you want to confirm your design parameters, okay? So you put in your instrumentation and monitoring, you want to make sure, okay? The second methodology is you want to optimize your design. So maybe it's you want to take out a layer of struts, maybe you want to, I can't think of anything else off the top of my head at the moment, but let's say optimization on your strutting or your anchoring or something like that. You have to have that, and then you put in place an observational approach, an instrumentation and monitoring strategy that will allow you to do that, okay? You also have that in your design as well, so that you know there's, I'll say a hold point, but please, the construction people out there, don't think it's a physical hold point, but you know there's a point in time in your construction program where your geotechs are going to say, yes, you put in the second layer struts, no, you can jump to, you can jump to the third layer, or something along those lines. That's where you need to go with the observational approach, okay? Also, and with the observational approach, I'll put in one lesson learned here. Particularly, I found it in the Middle East. Certain people don't understand the observational approach. They think the observational approach is a way to mitigate not having enough information. It's not. The observational approach is a way to optimize your design, confirm and or optimize your design. You should always go in with the observational approach with a design that works. The number of times I've come across people who have said, it's like, no, you just put this in, you don't need to do a design, we'll use the observational approach and prove it during construction. No, that's a recipe for failure and there will be a big disaster, okay?
All right, very good, very good. Dr. Marwan. No, Dr. Marwan is definitely a promoter of this. He's done his PhD thesis on testing and monitoring. But a question that I'd like to pose you from the authority viewpoint is, do we need to be more prescriptive in our codes in terms of forcing, or maybe encouraging the use of instrumentation and monitoring and observational approach, and utilizing that very good data that we get from instrumentation monitoring and reusing it in our design? What do you think from an authority perspective?
So from authority point of view, in my opinion, is very supportive for that approach. Specifically, I want to mention very important papers even done by you, Imran, and as well by Benoit, which related to back calculation using the instrumentation. One point I want to highlight it before coming in details in your question is also trying to use the new technologies in that. For example, we had in February Professor Soga coming here and presenting how we can use the fiber optic in the static load test. So instead of having strain gauges in each level, will give you the skin friction along the pile, which will change the whole equation and will change the whole design. So we support the consultant to present, for sure, the consultant, most of the owner listening to you, trying to bring all these new technologies, new ways of testing, which for sure will help to be used in the design. Back again to your questions, for sure, all the back calculation and monitoring is mentioned clearly in the code. And even though Neurocode, the new part, which is respect to geotechnical structures, they give even more room to that, and you can, even though use it in the second generation of Eurocode, highly supportive. But you cannot rely, in my opinion, many people, they come and say, okay, that back calculation then just 10 kilometers far away from my side. For sure, this is not acceptable. You have to invest. You have to do your own back calculation. You You have to do your own PTP, dilatometer, pressure meter, all this information which is related to additional testing for your site. For sure, you have the right, and you will be using all this information to optimize your design for sure for the deep foundation.
Okay, thank you, Dr. Marwan. Look, I think we do have one more question, but I was just going to maybe talk to Dr. Marwan. Like, we've got like 10 minutes left. Shall we do another question, or shall we open it to the
I think
to
the
the
floor,
floor?
they should ask and interact.
Okay. So now, question. So we've just opened it out to the floor. So if there's any questions from the audience that you'd like to ask any of the panelists. There's someone over there. Yeah, the mic is coming. If you just introduce yourself and then ask your question, please.
Hello,
Yeah.
I'm Dr. Prasad from ERI, Engineering and Research International, Abu Dhabi. Mr. Hadi correctly said about the correlation parameters which determines the uncertainty and the conservativeness. And my question to Dr. Marwan, that as a Dubai building code, as a Dubai authority, do we have any regional correlations so that as like we use it as there are a lot of different references are there. From there we derive, say, EAS, phi, and so forth. So is there anything in the pipeline as a design guideline that the Dubai municipality or the authority are going ahead with? Thank you.
So for correlation, I mean, we are depending, 100% if you open chapter F9 geotechniques in Dubai Building Code, is only referring to the Eurocode 7 and any correlation accepted by that. But still, as an authority, we are open for even correlation, but not any correlation just published in the papers or you have it. So maybe sometime we could accept something from ASH2 or something from maybe other codes, but it should be reasonable and it should be documented properly. But in general, we are referring in Eurocode, and all correlation which is accepted by Eurocode, it is accepted in Dubai Building Code. Yeah.
Yeah, thank you. I have one small question about the instrumentation point of view, where Ms. Viha has also said about the instrumentation that we are doing. As in Abu Dhabi region, there are lots of Sabkha areas are there, where if I do a soil investigation in August, September, October, there is no groundwater at the ground level. But if I do the work in January, February, March, the groundwater comes to the at the ground level. So long-term monitoring is there, that with the automatic piezometers and other things would definitely give a good advantage as a designer point of view. That's my input to this panel. Thank you.
Thank you. Thank you. Any other questions?
Dr. Mohammed?
Thank you. So it is not a question, it's rather a comment. My name is Professor Muhammad Araf from University of Sharjah. So I think, the universities can actually have a role in this. So as Finley correctly pointed out, that the purpose of the monitoring is either the trying to optimize or trying to learn, right? So and also to go beyond the current site and try to extrapolate for other sites or other places, then the university can have a role in putting this into perspective, right? Different projects, different sites, and collecting data from different places and put this into perspective. So I think, our role, research and collaborating with you guys and the authorities, this will play a role in trying to develop correlations that are regional for our region, or trying to, have some ground truth based on the data that you guys have And if sharing with us, that will, I think will play a role in learning and trying to extrapolate beyond a specific site or a specific project. Thank you.
Thank you, Dr. Mahmoud. Yeah, I think it's very, very important for us to have close links with academia. Okay, we have one more question here.
Good morning, and I'm Dr. Koni from Petrofac. I think it's not a question, it's an opinion, basically, a discussion. So I think everyone in this room believe that there is a over-conservatism, not even today, since many years, when there was no, compared to today, there was no enough information. Even after first 20 years, today we have comprehensive, exhaustive information. Still, we are having some limiting factors because of which geotech engineers or consultants not in a position to push that boundary and take better parameters. Till today, we're still using the same fundamental approach, plot all the data and they take average. If you are not confident, take little minimum values and proceeding. So I think this is not today, I mean many years, but what is the limiting factors? Definitely even today, if I do some design, eventually I have a limiting factor that whether client will accept or a PMC, EDNOC or Dubai municipality, whatever it is. Eventually the codal local practices are limiting factors. So definitely some transformation, some initiation has to come from that side rather than from the design side. We are okay to adopt. Eventually, the acceptance is still preventing us to push our boundaries a bit. So I think that is where some work has to be done. So we are doing the PTPs at a given percentage. Still, we are not in a position to use the data because we are not able to wait till we get the data and process and see whether we have a window for refining the data design. So that is something probably we need to look at, how to know the limiting factors, the client acceptance, local practices, or codal requirements. Those are the key front-end factors which are really preventing the design engineers or consultants to proceed a bit. Tomorrow I will discuss one of the case study where I got an opportunity to push a bit, not much, a bit. Thank you very much.
Okay, thank you. We have one more question.
Hello, this is Yazan from Senior Mobility Consultancy. It's just also a comment from my side, and thanks Rhea for your note that I think time is the big constraint, but also thanks Imran, because clients are a driving factor behind this time constraint. I believe it's what clients want to see is visual progress in projects, and to be frankly honest, geotechnical engineering is not about something you can see on site like visually, but it has a huge impact. So when we don't have enough time to analyze like geotechnical data that we have, we come with conservative parameters, and thus we have this over-conservatism. On the other hand, this brings out another topic, which is like, for example, desk studies. It's also another thing that clients don't want to fund, let's say, or they don't realize the importance of this. Thank you.
Okay, thank you. Any comeback? Or, okay, one more. Okay, one more question here.
Hi, my name is Ahmed Ihab from Modern Real Estate. Actually, I would like to start with a fun fact. Like, we are all talking about monitoring and the observational method. When Carl Terzaghi started the observational method description, he started with best estimate parameter to design, as Mr. Finlay correctly mentioned, and to have contingency plan, because we might underestimate. What we are currently discussing as like after 8 decades of observational method, we're just discussing having optimization. So we are back in our mind still having a conservative approach for selection of the parameters. So we are all expecting that our design can be optimized, but none of us, university side, government side, consultant side, we are thinking about having underestimation of our parameters and need for contingency plan if this underestimation is real. This is a fun fact starting with the observational method. My question, and I'm not trying to corner anybody, are we using the soil structure interaction in the best use of it? Like we are getting the most benefit? The question is related, for instance, for the pile draft. I know it's a debate happening everywhere. I don't know what is the correct approach to make it advancing in the market, in the common practice. We have in our head also a kind of unwritten law that we don't use the pile draft. So this is not the best use of the soil structure interaction, and we are missing the real behavior of the pile draft when we apply it only on pile springs. So I suggest to start from here, from a conference that contain employer side, consultant and contractor, to plan for the way forward to start adopting the pile draft. Maybe it's by some obligation from the government to have back analysis after doing any high-rise building, monitor the raft behavior, the pile resistance, as you correctly mentioned, Dr. Marwan. And from there, we create a database that we rely on, we trust as an obligation from all contractors to provide such back analysis or monitoring that can be back analyzed. And from that database, we start convincing whoever resists using the pile draft as a new plan for the way forward. That's
Okay, thank you very much for that. Do we have time for anyone to answer that question, or? I think the question, to summarize, was should we be doing more to try and convince using combined pile drafts?
The short answer is yes, but it's something Dr. Marwan knows, as I'm sure Hadi and Ray have been involved with this as well. The number of meetings over, I said I've been here 20 years, I'll say over the last 15 years I've been in with DM, and they think it's a wonderful idea, and then they'll say, no, all loads still onto the pile. There is also a balance there. Remember that in Dubai, we do have weak rocks, okay? So you don't get the efficiencies onto the pile raft that you would in, say, other areas where there's the harder rocks and things like that. So yes, you will definitely get efficiencies, maybe in the order of the 5 to 20 to 30 range, but it's not going to be the big 50% type of efficiencies you get.
Ray, want to answer?
Yeah, just very quickly. I think the combined pile draft needs to be looked at into case-to-case basis. So it can be that your certain project can go no piles straight away. So things like that, it doesn't necessarily allow you to jump onto that CPRF straight away and think of like more other solution that will be pushed the limit of the design itself. So yeah, I would relay back to Dr. Marwan in terms of this conversation, because it has been a lengthy discussion in the past as well.
Just I want to add this one thing. Usually, my opinion, everybody wait to the authority to give all the time the first step. But in my opinion, the first step should come from the industry, from the consultant. I never seen any consultant start doing monitoring and proving for us by monitoring that the load will be shared between the weak rock and the piles itself. So the story of combined pile raft foundation, just to correct you, pile raft, we are using pile raft, but combined pile raft foundation is not used here still. When it started long back, either in Austria or in Germany, where I studied with my professor Katzenbach, it was one of the requirements, and when they started, they have a full monitoring for the soil with the pressure cells, for the full pile, and they exactly have the behavior of the pile raft, and they confirm it based on the observational method, as you started your talk with that. So in my opinion, the first step should start from the industry, proving that doing that monitoring, prove it to the authority, prove it to the universities, prove it to the all parties here, and maybe we can go forward in approving or using or optimizing the foundation by Combined Raft Foundation. Thank you for that.
Very good, very good. Okay, thank you to all the panelists. I think we've probably run out of time now, but it's been very interesting discussion, and thanks to the audience as well for participating. All right. Thank you.